Now let us understand impulse momentum theorem. Now, what do you understand by the term momentum? So momentum is the product of mass and velocity. Okay, it is a vector quantity and it is a product of mass and velocity. Momentum is a parameter that determines the quantity of a motion. Okay, so momentum determines the quantity of a motion. What does that mean? Is if there is an object, okay, if this object has more mass, then this will have more motion. Okay, even if the velocity is small, okay, but the mass is more, in that case it will have more motion, it will tend to have more motion. And even if the mass is small but the velocity is more, in that case also it will have more motion. But if it has both mass as well as velocity that is more, then both are getting multiplied, so the momentum or the quantity of motion will be more. So momentum is nothing but a parameter that determines the quantity of a motion of an object. Now it is a vector quantity and the direction of this momentum would be in the direction of the velocity of the body. Okay, this is the velocity, then same direction the momentum will be directed for a body. Now by Newton's law we know that the force is nothing but the rate of change of momentum, that is dp by dt. Okay, now momentum can be written as mass into velocity dt. So let us not consider this second equation, only consider this equation. You can see if you take dt on the other side of this equation, you will get f dot dt is equal to dp. Okay, now this equation, this quantity on this side is known as the impulse. Okay, force into small time. Okay, on an object, if there is an object, you apply a force for a certain period of time, then that is known as the impulse. Okay, that experienced by that object. Okay, force acting on an object for a certain period of time, that product is nothing known but the impulse. Okay, understood. Now we'll try to integrate this equation. Okay, we have force that is acting on an object for a certain period of time. Now if you integrate this equation, okay, from t1 to t2, okay, this equation, force is acting on an object for a time period of this t1 to t2 is equal to this side also you can integrate for a momentum of p initial to p final momentum for an object. You can see this area under this curve is the product, and this is nothing but the change in momentum. This, okay, change in momentum. If you see, if you evaluate this side, then you can easily see that this is nothing but p final minus p initial. Okay, and this side is the impulse. You need to note the fact that in this equation, this force that is acting on an object is the external force. Okay, this is the external force. Here this is the external force acting on the system or the object. So you can see that p initial plus this t1 to t2 external force dt is equal to p final. So this equation is nothing but known as the impulse momentum theorem. Impulse momentum theorem. So the final momentum achieved by the object is nothing but the sum of the initial momentum of the object plus the impulse that is generated due to a external force for the time period of this. For time t1 to t2, the external force is acting on an object that is known as the impulse, and the sum of the impulse and the initial momentum will give you the final momentum. Okay, this equation is known as the impulse momentum theorem.